And now I will do this question by third way. Again, I will tell you that for the third way also, the theory will be same, but the mathematical way of dealing will be different. For this way, you will have to first understand a concept that if you want to check the coplanarity of two given lines, you know that you find the shortest distance between the two lines. And if the shortest distance is 0, it means the lines are coplanar. But that way is easy to use only when both the lines are given in symmetrical form. If one line is in symmetrical form and other line is in unsymmetrical form, and we want to check that the lines are coplanar or not, it will be very inconvenient to convert the unsymmetrical form of line into symmetrical form and then use the concept of shortest distance. I'm supposing that you know the meaning of unsymmetrical form and symmetrical form of line. If you don't know, just for clarity purpose, I'm telling you that when two planes, that is ax plus by plus cz plus d equal 0 and px plus qy plus rz plus s equal 0, when the two planes are representing a line, then that form is called unsymmetrical form. And when the lines are in the form of x minus x1 upon a, y minus y1 upon b, z minus z1 upon c, this form of line is called symmetrical form. If both the lines are of this form, that is, suppose the other line is x minus x2 upon p, y minus y2 upon q, z minus z2 upon r, and I want to check the lines are coplanar or not, we directly use the formula of finding the shortest distance. If the shortest distance comes to be 0, it means the lines are coplanar. If the shortest distance is non-zero, the lines are non-coplanar. You must be knowing that there is a direct formula for finding the shortest distance between the two lines. I'm supposing that the lines are non-parallel. It is very easy to check whether lines are parallel or not. But it will be very inconvenient to use this way if one line is in this form, other line is in this form, and we want to check the lines are coplanar or not. If we convert this line into symmetrical form first and then use a procedure which I have told you just now. But the better way to do in this case will be find a plane which passes through the intersection of these two planes, that is this plane plus lambda times this plane, and check is there any value of lambda for which this line lies in that plane. If it is possible to find the value of lambda, it means this line lies in that plane. That is, we will say these two lines are coplanar. If it is not possible to find the value of lambda, it means this line and this line are non-coplanar. Hence, out of the given lines, only that line can become the edge of tetrahedron if that line is lying in the plane P1 only or P2 only, or cuts both P1 and P2 at two different points, as I have already told you in the very beginning also. And to use the concept which I have told you just now, to check the coplanarity of two lines when one line is in unsymmetrical form, other line is in symmetrical form, first of all, I find a plane which passes through the intersection of these two planes. Why I am finding, you will understand after a few steps. The equation of plane which passes through the intersection of these two planes will have the equation 10x plus 15y plus 12z minus 60 plus lambda into minus 2x plus 5y plus 4z minus 20 equal 0. Note that this plane is of the type containing the line BD, hence passing through the intersection of P1 and P2. I will proceed in this way that out of given line, I will try to put every line in this plane. If the situation is of the type that by putting this line in this plane and I try to find the value of lambda, if lambda comes to be 0, that is this part becomes 0 and this part becomes non-zero, it means the line will be of the type AB or AD. If this part is non-zero and this part is 0, that the value of lambda is of the form non-zero upon 0, it will mean that the line is of the form BC or CD. If I am putting this line in this plane, if I get both as 0, it will mean that that line represents the line BD. If both are non-zero, it will mean that that line is of the type line in this plane. In this case, the line cannot become the edge of tetrahedron. And in case if it is not possible to find the value of lambda, it means that line is skew line with the line BD. Hence, it can become the edge and the line will be of the form AC. So far, I have told you the theory. Now I will use this theory mathematically. Let us take this case first. Let it be equal to alpha. I get x equal to 1, y equal to 1, z equal to 5 alpha plus 1. I put this point in this plane. I get 10 plus 15 plus 12 into 5 alpha plus 1 minus 60 plus lambda into minus 2 plus 5 plus 4 into 5 alpha plus 1 minus 20 equal to 0. That is, I get 60 alpha minus 23 plus lambda into 20 alpha minus 13 equal to 0. Now, this line can lie in this plane if this is true for every value of alpha. And if it is true for every value of alpha, we'll compare the coefficient of alpha on both sides. Right hand side can be written as 0 alpha plus 0. That is, I will get 60 plus 20 lambda equal to 0 and minus 23 minus 13 lambda equal to 0. Because I am getting two different values of lambda, it means this line cannot lie in this plane. Hence, I can say this line is of the type AC. Hence, it can become edge of the tetrahedron. Now, let us deal with the second case. Here the line is x minus 6 upon minus 5, y by 2, z by 3. And again let us suppose equal to alpha, x equal to 6 minus 5 alpha, y equal to 2 alpha, and z equal to 3 alpha. Again let us put this point in this plane. I get 10 into 6 minus 5 alpha plus 15 into 2 alpha plus 12 into 3 alpha minus 60 plus lambda into minus 2 into 6 minus 5 alpha plus 5 into 2 alpha plus 4 into 3 alpha minus 20 equal 0. That is, I get 60 minus 50 alpha plus 30 alpha plus 36 alpha minus 60 plus lambda into minus 12 plus 10 alpha plus 10 alpha plus 12 alpha minus 20 equal 0. That is, I will get 16 alpha plus lambda into 42 alpha minus 42 equal 0. And now this line can lie in this plane if this is true for every value of alpha. And now if it is true for every value of alpha, comparing the coefficient of alpha, I write right hand side as 0 alpha plus 0, and I will get 16 plus 42 lambda equal 0, comparing the coefficient of alpha, and minus 42 lambda equal 0. That is, from here I get the value of lambda as minus 16 by 42, and from here I get the value of lambda as 0. It means it is not possible to find the value of lambda so that this line can lie in this plane. Hence I can say this line is again of the type AC. This line is skew line with the line BD. Hence this line can become the edge of tetrahedron. And now the third case. To deal with this third case, let us suppose x upon minus 2 equal to y minus 4 by 5 equal to z by 4 as alpha. I get x equal to minus 2 alpha, y equal to 5 alpha plus 4, and z equal to 4 alpha. And again I will put this point in this plane. I get 10 into minus 2 alpha plus 15 into 5 alpha plus 4 plus 12 into 4 alpha minus 60. Note that the point was minus 2 alpha, 5 alpha plus 4 and 4 alpha plus lambda into minus 2 into minus 2 alpha plus 5 into 5 alpha plus 4 plus 4 into 4 alpha minus 20 equal to 0. That is, I get minus 20 alpha plus 75 alpha plus 60 plus 48 alpha minus 60 plus lambda into 4 alpha plus 25 alpha plus 20 plus 16 alpha minus 20 equal to 0. That is I get 93 alpha plus lambda into 45 alpha equal to 0. And right hand side can be written as 0 alpha plus 0. And as in previous case, here also again I will say, because this is true for every value of alpha, I will get 45 lambda plus 93 equal to 0. That is lambda equal to, as I have got a value of lambda and this value of lambda is non-zero, it means the line of the choice C is of the type that the line lies in a plane containing the line BD, and the plane is of the type somewhere of this type, and in that case the line will be somewhere in this plane, and in that case the line cannot become the edge of tetrahedron, because I told you that in case line lies in the plane containing the line BD, the line will be able to become the edge of tetrahedron if I get either lambda equal to 0, that is line will lie in this plane P1 only, and if I get the value of lambda in the form of non-zero upon 0, in that case the line will completely lie in the plane P2 only, and in case if the value of lambda comes to be of the form 0 upon 0, in that case line will be coinciding with BD. But if lambda is of the form 0 or non-zero upon 0, in that case the line can become the edge. In the case of lambda equal to 0, the line can be of the form AB or AD, and if the line is of the form non-zero upon 0, the line can be of the type CB or CD. And using this theory, I'm going to do the last case. Again I'll say x upon 1 equal to y minus 4 by minus 2 equal to z by 3, let it be equal to alpha. X is equal to alpha, y equal to 4 minus 2 alpha, and z equal to 3 alpha. And now putting this point in this plane, I get 10 into alpha plus 15 into 4 minus 2 alpha plus 12 into 3 alpha minus 60 plus lambda into minus 2 alpha plus 5 into 4 minus 2 alpha plus 4 into 3 alpha minus 20 equal 0. That is, I will get 10 alpha plus 60 minus 30 alpha plus 36 alpha minus 60 plus lambda into minus 2 alpha plus 20 minus 10 alpha plus 12 alpha minus 20 equal to 0. That is, I get 16 alpha plus lambda into 0 equal to 0. And because I want this to be true for every value of alpha, now it will be true for every value of alpha if lambda is of the form some constant upon 0. If lambda is of the form say a upon 0, then you get 16 into alpha into 0 plus a into 0 equal to 0. You may be thinking that upon 0 is not allowed in mathematics. But note that just like in 2D, if you are finding a line passing through the intersection of these two lines, so this is L1 equal 0 and this is L2 equal 0, then any line passing through the intersection is of the form L1 plus lambda L2 equal 0, and lambda is found with the help of some other condition given in the question. If lambda is found to be 0 by the given condition in the question, it means L1 itself is the line which is satisfying the given condition. If lambda is found to be of the form some constant upon 0, note that in this case it is not undefined. Actually in this case L2 is the line which is satisfying the given condition, whatever is the condition. In this case we will have to allow constant upon 0, because if we don't allow lambda to be in the form of upon 0 form, then we'll never get the line L2 only if L2 is satisfying the given condition. Actually, some of you may be thinking that what I am tweaking, this thing will become clear if you see my video lecture of coordinate geometry. Otherwise, it is not difficult to see also if you have already done the practice of questions of straight line of coordinate geometry for JEE at least mains level. In board level, this type of situations doesn't happen, but in JEE level, this type of situations can come. Hence, the main concept I want to tell you is whenever you have to find a line passing through the intersection of these two lines, then line is of this form, and lambda in this case can be in the form of constant upon 0, that is allowed. And here lambda is of the form a upon 0, because if 0 comes here, 0 into anything becomes 0 and it will become true for every value of alpha. Still, if you have not understood, I can speak the same thing in an easy language. Say if you had written this plane plus lambda times this plane, in that case you will reach at the position 16 alpha lambda plus 0 equal 0, and it will be true for every value of alpha if lambda is 0. And because we have got the answer lambda equal 0, and I have told you if lambda is found to be 0 or constant upon 0, then situation will be of the type that the line is of the form AB or AD or BC or CD. In this case, we have written P1 here and equation of the line P2 here. For this type of situations, if we find lambda equal 0, then the edge can be of the form AB or AD. If lambda is some constant upon 0 form, in that case, the given equation will represent the edge as BC or CD. And as I have taken the plane passing through the intersection of these two planes in this form, hence Had I got lambda equal 0, then in that case, this equation would have represented as AB or AD. But presently, because lambda is found to be in the form of constant upon 0, hence the given equation will be representing the edge of the type BC or CD.